In this lesson, we want to review equations of lines. So a pretty common task in algebra is being able to write the equation of a line given certain information. So additionally, you may have to change between different forms of a line to perform a specific task. So as we kind of progress through the course, you'll see that in some cases you need one form of the line, it's more advantageous. In other cases, you will need a different form of the line. So what we're going to do today is discuss the slope-intercept form, the point-slope form, and the standard form. And we'll show how to kind of go back and forth between those different forms. So we're going to begin with slope-intercept form, which we previously talked about. So basically, slope-intercept form allows us to immediately know the slope and the y-intercept by kind of observing the equation. Okay, so we have y equals m, which is our slope. This is our slope, times x plus b, which is the y-intercept, right? You can see that if you plugged in a 0 for x, you would get 0 comma b as the y-intercept. All right, so where does slope-intercept form come from? Well, essentially, if you take your slope formula, which we already talked about, m the slope is equal to the difference in y values. So you have y sub 2 minus y sub 1 over the difference in x values, x sub 2 minus x sub 1. Again, where you say x sub 2 minus x sub 1 is not equal to 0. Because if this is 0, you have a vertical line and the slope is undefined. But following this slope formula, if I just say I know that the y-intercept would occur at 0 comma b. So let's just say I have that. And let's say my other point is just x comma y. Okay, so let's say I replace 0 comma b with my x sub 1, y sub 1. So let's say this is x sub 1, y sub 1. Let's say this is x sub 2, y sub 2. And we're just going to plug in. Okay, we're just going to plug in. So for y sub 2, I'm going to have just y, right? So that's what I'm plugging in. So m equals y minus. For y sub 1, I have b. This is over. For x sub 2, I have x. And then for x sub 1, I have 0. X minus 0 is just x, right? So we can go ahead and just write that like that. And then what I can do is I can multiply both sides of the equation by x to clear that denominator. So this will be gone. And what I have is, I have m times x is equal to y minus b. So how can I get y by itself? I can just add b to both sides of the equation. Let's just kind of finish this up. We would have what? We would have mx plus b is equal to y, which I could flip around and put y out in front and say y equals m the slope times x plus b my y-intercept. So pretty simple to derive that. And we know our slope is m, since again, this came from the slope formula. And we know that b is the y-coordinate for the y-intercept. Since we plugged in a 0 comma b, the y-intercept, that got plugged in as a point. All right, so a pretty common task in this section is to be given a slope and a y-intercept and to be asked to write the slope-intercept form of that line. So suppose we're given a slope m of -3/4 and a y-intercept of 0 comma 7. So again, this right here, this is my b. We already know what m is. So just match up the format. Y equals m times x plus b. Again, just plug in. It's very simple. Y equals m, which is -3/4, times x, and then plus b. B is 7, right? It's the y-coordinate for the y-intercept. So plus 7. All right, what about m equals 4/5 and a y-intercept that occurs at 0 comma -4? So again, this guy right here, the y-coordinate for the y-intercept, that's your b. So you get y equals m the slope times x plus b. So y equals m is 4/5, times x. And then you could do plus -4, you could just do -4. So y equals 4/5 x minus 4. All right, so in some cases, we're not given enough information to immediately write the equation of a line. And sometimes we're just given the slope and a point on the line, or we might be given 2 points on the line. When this occurs, we can use point-slope form. And then from there, we can go into slope-intercept form, okay? So point-slope form, this is something you should remember, a point on the line and the slope, okay? That's the normal situation you'll be given when you want to use this form. So this kind of x sub 1 and y sub 1, that's going to be our known point, and m, our slope, is going to be known. Or sometimes we'll get 2 points on the line, and from that, we can use one of those points, and we can calculate the slope using slope formula. All right, so where does this guy come from? Well, if we start with our slope formula, and let's say we say m is equal to, again, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And let's just say that x sub 1, y sub 1 is the known point, and x comma y is the unknown point. So I'm just going to change this notation up just a little bit, but it's the same thing, right? You've got the difference in y values over the difference in x values. All I'm going to do, let me just kind of slide this down. To get this, I'm just going to multiply both sides by the quantity x minus x sub 1. So I'll multiply this by x minus x sub 1. And again, I can put the m out in front. So put that out here. And this cancels with this. And what I'm going to have is, I'm going to have m times the quantity x minus x sub 1 is equal to y minus y sub 1. Okay, it's exactly what we have here. It's just in a different order. I can erase this and kind of flip this around. It makes no difference. I can say this is y minus y sub 1 is equal to m times the quantity x minus x sub 1. Okay, so this came straight from the slope formula. All right, so let's suppose we wanted to write the equation of a line given the following information. We're given the slope m, which is 3, and we're given one point on the line, which is 5, 7. So all we need to do is just plug into the point slope form. So again, that's y minus y sub 1 is equal to m the slope times the quantity x minus x sub 1. Again, m is 3, so I would just plug in a 3 there. So let me put y minus y sub 1 equals, I'm going to put a 3 there, times the quantity x minus x sub 1. Now this is my given point. This is what you would label as x sub 1, y sub 1. So what I'm going to do is I'm going to erase this. I'm going to plug in my y sub 1, which is 7. I'm going to erase this and plug in my x sub 1, which is 5. And then from here, I can just solve for y, right? So I'd have it in slope-intercept form. So y minus 7 is equal to 3 times x is 3x. And then minus 3 times 5 is 15. And let me scroll down and get a little room going. So let me add 7 to both sides of the equation, and I'll be done, right? So this is going to cancel. So my slope-intercept form is y is equal to 3 times x, and then negative 15 plus 7 is going to be negative 8. So you just put minus 8. So y equals 3x minus 8. So again, if you get confused by this, just remember for point slope form, just follow the name. I know a point and the slope, or it could be that you get 2 points, right? You can calculate the slope from that. So you would still know a point and the slope. If you're given a y-intercept and a slope directly, then you can immediately put it in slope-intercept form. Okay, so that's the difference between these two and where you're going to use it in which situation. So again, I've given another situation where I have a point, which is 2 comma negative 4, and the slope m equals 1/5. So again, I have a point in the slope, so I want to use point slope form. So y minus y sub 1 equals m times the quantity x minus x sub 1. Okay, so just plug in y minus, for y sub 1, again, just label this as x sub 1, y sub 1. So y sub 1 is negative 4, minus the negative 4 is plus 4. And then m is 1/5. And then times the quantity, we have x minus x sub 1, which is 2. And then I can just solve this for y, and I'll have my slope-intercept form. So y plus 4 is equal to, we'd have 1/5 x. And then minus, you'd have 1/5 times 2, which is 2/5. Okay, so let's go ahead and solve this guy for y. So y is going to be equal to what? If I subtract 4 away from each side of the equation, let me do this over here as getting a common denominator. If I multiply 4 by 5 over 5, it would be minus 20 over 5. Okay, 20 over 5 again is the same as 4, so I just subtracted 4 away from each side. So I'm going to have 1/5 times x, and then you'd have basically negative 2 minus 20, which would be negative 22. So I'll put minus 22, and then over the common denominator of 5. All right, so a more tedious scenario occurs when you're just given 2 points on the line and you're asked to write the equation of a line. So this is one of those scenarios that can get kind of confusing. You still want to use point slope form because you know a point, right? You have 2 of them. You can use either one. And you know the slope because you can calculate the slope using a slope formula. So m is equal to what? It's the change in y values, so y sub 2 minus y sub 1, over the change in x values, x sub 2 minus x sub 1. Right? So the change or difference in y values over the change or difference in x values. So I can label this as x sub 1, y sub 1, and this is x sub 2, y sub 2. Again, you can change that up, it doesn't matter. So for y sub 2, I have 7. So let's plug that in. For y sub 1, I have a negative 5. Then for x sub 2, I have 7. And for x sub 1, I have 3. So what I'm going to have here is what? 7 minus the negative 5 is 7 plus 5. That's 12. This is over. 7 minus 3 is 4. So 12 over 4 is 3. So now I know my slope is 3. So let me erase this and just put m equals 3. So here's where it can get confusing. A lot of students will at this point be confused as to which point they need to plug in. And the answer is you can plug in either one, right? They're both points on the line, so it doesn't matter which one you choose. But this labeling will get a little confusing. So let me just show you this. I'm going to use each one. I'm going to say this is x1, y1 to start. And I'm going to plug into my point slope form, and then I'll do the other point. I'll show you it's the same. So y minus y sub 1 is equal to m times the quantity x minus x sub 1. Okay, so we're just going to plug in. So let me just do this above. Y minus y sub 1 is going to be negative 5. So that's plus 5. And this equals, m is my slope, it's 3. Times the quantity, we're going to have x minus, again, for x sub 1, I have 3. So let me erase this real quick. Let's solve this for y. So y is going to be equal to y. If I subtract 5 away from each side of the equation, over here on the right, 3 times x is 3x, and then minus 3 times 3 is 9, and then minus 5. Negative 9 minus 5 is going to be negative 14, okay? So you get y equals 3x minus 14. So let me erase this. So we have, let me just kind of put this over here. We have y equals 3x minus 14. Okay, so let me use this guy as a point now. I'll show you get the same thing. So x sub 1, y sub 1. Okay, so when we plug in, we have y minus y sub 1 equals m times the quantity x minus x sub 1. Okay, so y sub 1 is 7. So this is 7. And x sub 1 is going to be 7 as well. And m, my slope, is 3. So at this point, you might say, hey, that doesn't look the same. But when you solve it for y, you're going to get the exact same equation as you got using this point over here. Okay, so y minus 7 equals, you'll have 3x minus 21. Add 7 to both sides of the equation. And again, you're going to get that guy. You would have what? This cancels. You would have y is equal to, you'd have your 3x. And then negative 21 plus 7 is negative 14. So again, either way, it's the same, right? So don't get confused about which point to use. No matter what point you use, you end up with the same equation when it's put in slope-intercept form. All right, let's try another one. So now we're given 2 points, 2 comma 14 and 6 comma 4. Again, just go ahead and calculate your slope first. So m is equal to, I'm going to go as this one with x sub 2, y sub 2, and I'll say this one is x sub 1, y sub 1. Again, it doesn't matter. So we'd have y sub 2 minus y sub 1. So 14 minus 4 is going to be 10, right? So I'll just write 10 here, just save a little time. And then x sub 2 is 2, x sub 1 is 6. So 2 minus 6, x sub 2 minus x sub 1, so 2 minus 6 is negative 4. So my slope here is going to be what? If I divide each by 2, I get 5 over 2, and then it's negative, so negative 5 halves. Okay, so now that I know my slope and a point on the line, so a point on the line, and pick either one. Again, it doesn't matter. I just showed you that. Let's just pick this one. We'll say this is x sub 1, y sub 1. And again, m, my slope, is negative 5 halves. Plug into the point slope form. So we have y minus y sub 1 is equal to m, the slope, times the quantity x minus x sub 1. So for y sub 1, I'm plugging in a 14. For x sub 1, I'm plugging in a 2. For m, I'm plugging in a negative 5 halves. Okay, so let's just solve this for y, and we'll be done. So we'll have y minus 14 is equal to negative 5 halves times x is negative 5 halves x. And then negative 5 halves times negative 2. Let's just do this off to kind of the side. Let's put plus negative 5 halves times negative 2. We can clearly see the 2's would cancel. Negative times negative is positive, so you basically have positive 5 there. Okay, so we'll put plus 5. Let me scroll down and get some room going. So at this point, I just want to add 14 to both sides of the equation. So we can see that this would cancel over here. And now you have y is equal to negative 5 halves times x, and then plus 5 plus 14 is 19. Okay, so that would be your equation in slope-intercept form. Y equals negative 5 halves x plus 19. All right, let's talk about something that's a little bit confusing because the definition is going to vary from textbook to textbook and also based on which class you're in. Okay, so something known as the standard form of a line, this is something very useful. It looks like this. You have a times x plus b times y is equal to c, where a is the coefficient of x, b is the coefficient of y, and c is some constant. Okay, so an example would be something like 5x plus 2y equals 3. Okay, my a here is 5, my b here is 2, and my 3 here is c. So we need to understand what A, B, and C represent because they're going to be used a lot in our formulas. So for most textbooks, when we talk about A, B, and C, we say that they need to be integers. Okay, this is kind of a stricter definition. So we would say A, B, and C are integers. Okay, are integers. But as you move higher in math, this is kind of relaxed. Okay, and we say A, B, and C are just any real numbers. Okay, it just needs to be in this format. Now, we also say that, again, in the stricter definition, this is something you generally see in high school, that A is greater than or equal to 0. So A, the coefficient of X, B, the coefficient of Y, and C, the constant, are integers. And A, the coefficient of X, is going to be non-negative, right? So it's 0 or some positive number. Now, from this form, we can quickly get a lot of information. We can see that if I plugged in a 0 for X, okay, a 0 for X, this would go away. I would have by is equal to C. I would divide both sides by B, and I would find out that my y-intercept occurs at what? So there, y would be equal to C over B. So C over B would be the y-coordinate for my y-intercept. Now, I can also get the slope pretty quickly from this as well. If I start with ax plus by equals C, I know if I solve this for y, the coefficient of my variable x is my slope. So if I subtract ax away from each side of the equation, I would have what? I would have by is equal to negative ax and then plus c. So if I just divide both sides of the equation by b, what do I get? Well, what I'm going to have is what? This cancels. I'll have y is equal to the negative of a over b times x and then plus c over b. Again, if you match this up with slope-intercept form, we're using different kind of letters, but it's the same thing. Y equals m the slope times x plus b the y-intercept. M here is negative a over b. And then b here, my y-intercept occurs at 0, comma, c over b, which we just talked about a minute ago. And I'll prove this to you later on with some examples that we can get the slope either as the coefficient of x when this guy's solved for y, or if it's in standard form, we could just have the negative of a, the coefficient of x, over b, the coefficient of y. All right, so let's take a look at an example. So suppose you're given y equals 5/3 x minus 3, and you're told to write this in standard form, again, with the stricter version, where a, b, and c are integers, and a is non-negative. So ax plus by equals c. Just want to put in this format. So here's my something times x. This is my ax, right? So let's subtract this away from each side of the equation. And that's going to give me what? I'll do this over here. You'll have negative 5/3 times x, and then plus y is equal to negative 3. Now, at this point, okay, if you were using kind of a looser definition where a, b, and c are real numbers, then you're basically done, right? This is in standard form. And I can show you really quickly, okay, that the slope is the same. Again, my slope, when it's in standard form, m is equal to the negative of a over b. In this case, a is negative 5/3, and b is going to be positive 1, right? This guy has an implied coefficient of 1. So negative of negative 5/3, so the negative of negative 5/3 is positive 5/3, and this would be divided by 1. Anything divided by 1 is just itself, so you see you get a slope of 5/3, which is exactly what you get here, right? The coefficient of x. So it's a quick way to calculate the slope if it's in standard form. It's the negative of a, the coefficient of x, over b, the coefficient of y, okay? But again, for our purposes, if we want a, b, and c to be integers and a to be non-negative, we need to do a little bit of work, okay? So the first thing is to consider, how can I make this into an integer? Well, I can multiply both sides of the equation by 3 to clear the denominator. But at the same time, I want it to be non-negative. So what I could do is I could just multiply by negative 3, and that would fix both problems, right? So if I multiply this side by negative 3, and this side by negative 3 to make it legal, negative 3 times negative 5/3, the negative times negative would be positive, and then the denominators would cancel, right? 3 over 3 is 1, so I would just have 5 times x, and then you'd have negative 3 times y, which would be negative 3y, and this equals negative 3 times negative 3 is positive 9, okay? And again, even though I transformed it to look different, the slope is still the same. It's again, m is equal to negative a over b. What is a? A in this case is 5 now. What is b? B is negative 3. What is negative 5 over negative 3? Again, that's 5/3. So either way, our slope is the same, right? We have 5/3 here, we have 5/3 here. All right, so let's put everything together in one kind of last example. So suppose you're given 2 points on a line and you're told to write it in standard form. And again, you're going to use the stricter definition. So you're given points 10, 6 and -5, -12. Well, you're not going to immediately put this in standard form, and you can't immediately put it in slope-intercept form. You got to use your point-slope form. Again, if you know a point and the slope, you use point-slope form. In this case, I can generate a slope, and I know a point. So my slope formula, again, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So let's label this as x sub 1, y sub 1. Let's label this as x sub 2, y sub 2. So let's go ahead and plug in. So for y sub 2, I have a -12. For y sub 1, I have a 6. For x sub 2, I have a -5. And for x sub 1, I have a 10. Okay? So if I think about -12 minus 6, that's -18. So this is -18. -5 minus 10 is -15. So I know immediately this is going to be positive, right? Because negative over negative is positive. Each here is divisible by 3. If I divide 18 by 3, I get 6. If I divide 15 by 3, I get 5. So it looks like my slope is going to be 6/5. Okay, so my slope is 6/5. Okay, so from here, I can just use a point. It doesn't matter, again, which one I use. Let's just go ahead and take this one. We'll say this is x sub 1, y sub 1. And I'm going to plug into my point slope form. Y minus y sub 1 is equal to m times the quantity x minus x sub 1. So for y sub 1, it's 6. For m, it's 6/5. And for x sub 1, it's going to be 10. Okay? Let me scroll down just a little bit. All right, so we'll have y minus 6 is equal to 6/5 times x is 6/5 x. And then minus 6/5 times 10. We can cancel this 5 with this 10. That'll be a 2 up here. 2 times 6 is 12. So we'll have minus 12 there. And again, to finish this up, let me add 6 to both sides of the equation. This will cancel. And we'll have y is equal to 6/5 x. And then -12 plus 6 is minus 6. Okay? So let me just scroll down. So now we want it in standard form. And to do that, again, I want ax plus by is equal to c. So let's move this over here on the left. So we're going to subtract 6/5 x away from each side of the equation. And of course, on the right side, it cancels. You'll have -6/5 x. And then plus y is equal to -6. So again, at this point, it matches this format if you were using a definition where a, the coefficient of x, b, the coefficient of y, and c, the constant, were real numbers. But again, we want to use the stricter definition. So what I'm going to do is a little bit of additional work. So if I want to clear this denominator here, right, because I don't want this to be a fraction, I want it to be an integer. And I want to get rid of this negative here, because again, I want it to be non-negative. I can just multiply both sides of the equation by -5, right? It would change the negative to positive, and it would clear the denominator. So let's multiply this by -5 to make it legal. So -5 times -6/5 would just be positive 6, then times x. -5 times y would be minus 5y. And this equals, you have -6 times -5, which is 30. Again, you can use this, 6x minus 5y equals 30. I can show you that everything is the same, right? We found that y was equal to 6/5 x minus 6, okay? Again, my m, my slope, is what? It's the negative of a, the coefficient of x, over b, the coefficient of y. Okay, so make sure you take the negative and the 5. What do we get? We get 6/5, right? Which is exactly what we got here, okay? So that's pretty quick. And then again, the y-intercept occurs at c over b. So the y-intercept is c over b. So then here we know it's -6. C is 30. C is 30. B is -5. And again, you get the same thing. 30 over -5 is -6. So I know the y-intercept would occur at 0, -6, just as it tells me here in slope-intercept form.